Hello again, everyone. Welcome to another Wallet Making Wednesday. Today is all about roughing and finishing strategies in Fusion 360 because we're going to be making our tightest tolerance part for our magnetic case wallet, the magnetic latch, today. Now, for people without large commercial CNC machines, it can be kind of tough to hit the tolerances you might want in the parts you're making. So that's why we're emphasizing having really quality roughing and finishing strategies today in Fusion 360. That basically helps you avoid having a giant box of fail, because these magnetic latches all took many attempts to finally get right. But if you have really good roughing and finishing strategies, you'll avoid some of these waste parts and be able to make parts quality and with fairly tight tolerances on the first try. So without further ado, let's get into Fusion 360. Hello again, everyone. Today we're going to be milling out our third main component for our magnetic case wallet, and that is the magnetic latch. It's milled from the same 10mm stock material as the base plate. And before we get into the cam view, I'm just going to show you a couple things in the model view. And one little trick I use to quickly simulate how it should function once it's cut out. So instead of going through a joint or an assembly like you're supposed to, if you don't want to take the time to do that, you can just simulate rotation by right-clicking on the body, hitting move or copy, hit set pivot, and you can select the outer contour of the screw hole, hit the green arrow. So now I can rotate this body just by using the move command without having to take the time to make a proper joint. If you just need to simulate something quickly, that's an easy way to do it. So this is our highest tolerance component, and we're going to be paying special attention to our roughing and finishing strategies, which is going to be the theme for today's cam. You can see here how the latch functions. There's a screw hole for a neodymium magnet in the latch, and it locks into the neodymium magnet embedded into the base plate. Okay, let's jump into the cam. Okay, so here we have our palette of magnetic latches ready to go. Our stock material is G10, and our thickness is 10mm, just like our base plate from before. Before we get into the operations, I'm going to explain briefly what I mean by roughing and finishing strategies. By roughing, I mean any operation whose goal is to clear out the bulk of your material in your model without trying to hit the tolerances specifically, whereas your finishing strategy is intended to hit the tolerances of your model as precisely as possible. Now, without a commercial CNC machine, it's very important to have a very well-defined roughing and finishing strategy. Because I know the machine will deflect anything from 0.3 to 0.5 millimeters, I'm going to run the roughing strategy as fast as possible without breaking the machine or tool. I'll also run a very fast finishing strategy because that is a lot easier to control the tolerances of rather than running a very low speed combined roughing and finishing strategy. Okay, so that said, let's get into our operations. Now, the best way to start when trying to choose your first operation is essentially just look at the largest feature in your model and pick the operation that will clear it out the most efficiently. So for us, that's going to be 3D adaptive. I'm going to choose 3D adaptive because I also recognize that I have 4 different layers of heights in this model. I have this bottom part, I have this part up here, I have this part by the pivot, and I have this top thinner face here. So 3D adaptive is going to be our best strategy to start off. So our tool's already selected. Now, because this is going to be a high-speed roughing operation, I'm going to set this to 800 millimeters per minute. Our ramp, which is going to be a helix, set that to 1000. Get our lead-ins and lead-outs fairly close to our cutting feed rate. Okay, so we're going to start selecting our geometry. So machining boundary, I'm going to choose silhouette. We're not going to need rest machining. This is our first operation. Now for our model, I'm going to select our 4 faces. All right, next is the height tab. Our bottom height, we're just going to leave that on the model bottom. Everything looks good there. Our passes tab. Now our optimal load, that's pretty decent. We'll just keep it at a nice even number, 1.25 millimeters. Machining cavities is on by default. We're going to turn on flat area detection. We're going to turn off stock to leave. Because I know the machine will deflect when doing this high-speed roughing operation, I'm just going to leave stock to leave off because I just know that it's going to deflect by about 0.5 millimeter, potentially. That's okay. We're going to be cleaning it up with the finishing strategy later. Let's go over to our linking tab. Okay, I want our stay down level to be most. Our lift height, keep that at 0. Our non-engagement feed rate, that's very important. I set that to whatever my G0 rapid speed is for your machine. Our helix ramp, I'm going to set my ramp clearance height to 1 millimeter to get that bore started close to the stock as possible. Okay, let's generate that. All right, so that's a good looking operation. It's going to start by boring into the widest part of the material, and then start doing its adaptive clearing on all 4 different levels, which is why 3D adaptive was chosen, because it lets you choose different heights in your model. And we can see all of these yellow lines. All of that is your non-engagement feed rate. So you want, whenever the tool is moving on these yellow lines, you want that to be the absolute maximum speed you can. Okay, our next strategy is going to start cleaning up our adaptive roughing strategy. So now we're going to go into 2D pocket. Same tool is selected. Now we're going to keep the exact same high speed feed rates as before. I'm going to go into geometry. Because this is an open pocket, I'm going to select the actual pocket edge. Make sure my red arrow is on the correct side. Go to stock contours. Now select that stock contour, and you should end up looking at something like this. Now our heights tab, this looks pretty good. Selected contours as our bottom height by default. That's what you want to look out for. And our passes tab, because this is a high speed finishing pass, I want the step over to be as high as possible. So choose a nice even number, 3 millimeters, because it's a 1/8 inch end mill. Turn on smoothing. Now our stock to leave, this is what's important here. So we're going to want negative stock to leave. So we want to take off, say, another 0.15 millimeters on our radial edge, and our axial edge, let's keep it at 0 so we can see the tool path. Our linking, I'm going to pick a very small lead in and lead out, 0.1 millimeters, because it's going to be plunging down very close to the edge of the area we just finished clearing. We're going to hit OK to generate that. All right, so that's our finishing strategy for our bottom of the latch. Now to actually put in our real axial value, I'm just going to depress this by 0.4 millimeters. So this is essentially cleaning up whatever the previous model had left, or whatever the previous model had left. due to the machine deflection. Okay, one thing that I forgot to do in this operation is to select both ways. You go into your passes tab, hit both ways. It's essentially going to mill climb and conventional. We'll turn off the axial stock to leave so you can see that. So this will save a lot of time, especially if you're not going to be milling out a significant amount of material at any significant depth. Using both ways is a great way to help save some time in your finishing passes. Okay, our next operation is essentially the same as our previous one, another 2D pocket. So I'm just going to duplicate our previous operation by right-clicking, hitting duplicate. So now all I need to change is the geometry. I'm going to go into Edit, clear out our old geometry, and start with our new pocket selection. I'm going to select this pocket in here. Now our red arrow is on the wrong side, as you can see by the blue highlighted area. So I'm going to hit that red arrow. So now the contour is open. It is open facing the face of the pivot. So in stock selections, we're just going to select the outer boundaries of the face. And we're going to go into passes, and for this finishing operation, we're not going to have any stock to leave. We're going to hit OK. And that's our finishing operation for the pivot pocket. Now we're going to continue to duplicate this exact same operation and do the face on the other side of the latch. We're going to go into Edit, move over to the other side, clear our previous geometry, our pocket selection. Alright, the red arrow is on the right side this time. Select our stock contours, and hit OK. Alright, so that's our finishing operation for our magnet bore face. And as a brief note, at this point, once you start duplicating and making multiples of operations, it helps to start naming them, because they can quickly become confusing. Okay, so now that we have the main area of our latch cleared out and finished, we're going to start thinking about cutting out the outside of our latch. Now, to get a good idea of why we have to pay special attention here, we're just going to go into simulation right now, turn on our stock, and skip right to the very end of the simulation to see what the material looks like. Okay, so we can tell here, if we want to start cutting this material out, we have an extremely thin 1 to 1.5 millimeter thin section on the bottom of the latch, but as we get to the outside, we're still at close to a 10 millimeter thick material. 8 to 9 millimeters of material to get through. So we need to start evening this part of our latch out, the top part of the latch, before we can think about cutting the entire thing out. So this is a good example of why simulating halfway through your operation can help you, or your set of operations can help you get a better idea of what step to take next if you find yourself stuck and not sure where to go from there. Okay, so this calls for a 2D contour. We're going to go into our geometry and hold down the Alt key and select the front face, or I guess the top face of our latch. We're going to go to our heights tab next, and for our bottom height, we're going to select the lowest geometry, or the face with the lowest or the thinnest geometry that isn't all the way to the bottom. So for bottom height, we're going to, instead of select a contour, we're going to just hit selection, and then for our bottom reference, we're going to hit this line here. Offset, leave it at 0. Okay, in our passes tab, we're going to turn on smoothing, turn on multiple depths, use a maximum roughing step down of 2 millimeters, rough final, turn on even step downs. Now because this is such a thin depth, we're going to increase our feed rate to 1,000 millimeters per minute. And we're going to hit OK and see what that gives us. Alright, so as you can see, these contours are going to even out the back side, or the front side of the latch. So our next operation will be able to cut out the entire thing in nice one smooth, even pass without running into a tall block of thick material. Okay, so I'll just name this Edge 2D Contour. Alright, before we actually cut out the entire profile of the latch, we're going to drill our holes for our pivots as well as our magnet. So we're going to hit drill, and the first thing I like doing is selecting the type of cycle. So for cycle, I'm going to immediately go to bore milling. Okay, let's go back to our feed rates. Cutting feed rate, put that at 600. Our cycle, our diameter is going to be 4.8 millimeters. Our geometry, we're going to do our magnet first. And for our heights tab, our top height can be whole top because we've cleared out the material. There's no need to start from the stock top. So we can wrap it all the way down to the whole top. And for the feed height, I'm going to tell it to wrap it down to 1 millimeter above our top hole. Now for our pitch, I'm going to change this to 0.3 millimeters. That means it'll take some nice even, or some nice shallow spirals to the bottom of the hole. I hit OK. Now I'm going to duplicate this operation, and we're going to now drill our hole for our screw pivot. I'm going to go into the geometry tab, deselect the previous face, select the new face. Our heights can be the same because it's just referencing the hole that's been selected. That's actually not true. In heights, we actually have to change this to negative. I like changing it to -2. Going down under the stock material by at least 2 millimeters, make sure you have a nice, good edge finish on your hole. It really depends on the material, though. Okay. Now for our cycle, I know this hole is about 3.65 millimeters. We're going to hit OK. Now I should note that there are many ways to drill holes in Fusion. For instance, if I select 2D bore, when I select the geometry, it will actually show you in the edit view what your pitch looks like. You actually get to see the toolpaths. But the reference is always the geometry. So whatever your model is set to, you're essentially glued to that reference point. Now for prototyping purposes, I prefer using the drill bore operation because it lets you select the diameter manually. So instead of going in, switching out of your cam view, going to model, having to change the offsets, change your model around just to change the diameter of a hole, you can just change one number in this operation. It really comes down to your personal preference. That's the great thing about Fusion. There's usually 5 or 6 ways to do the exact same thing. Okay, now we're going to cut out the profile of the latch. So that's going to be a 2D contour operation. We're cutting feed rate. We're going to be cutting around about 3mm thick material. So we're going to put that to 400 millimeters per minute cutting feed rate. Nice and easy. Take our lead-ins and lead-outs down a bit. Our plunge is a nice easy 50 millimeters per minute. And let's select our geometry, which is going to be our bottom contour. We're going to turn on tabs, and we're going to get away with just doing a single tab for this operation. I'm going to choose the point of the model that I know is going to be hand finished. That's going to be right there. All right, before I mess with tab settings, I'm going to go over to my heights tab and deal with the offsets for the bottom height. I want this to go down -2 millimeters. Our feed height, 1 millimeter above our top height. Go back to our geometry tab, and we can set better tab width as well as tab height. Now I want this to be, because this is our only tab, I'm going to make it a little bit taller. Okay, we're going to go to our passes tab, turn on smoothing, turn on feed optimization. So the points that we need to be very precise in this model are this inner radius in here, as well as in here. So we're going to make sure our reduced feed radius is higher than the radius of the largest feature that we want the feed rate to apply to. So use something like 4 millimeters. Reduce feed distance, set that to 2 millimeters. Our reduced feed rate, let's cut that right in half. And we're going to turn off inner corners. Okay, so let's go to our linking tab. Our lead-in is going to be, let's set our entry position first. Our entry position, we want it to be right on top of the tab. If there's any type of deflection, then it's just going to get ground off because that's our hand finishing section. Our lead-in, we're going to make that nice and shallow. We're going to hit OK and see what that gives us. All right, so we can see here, our feed rate optimization is going to really slow down in this corner. Make sure it's nice and precise. All right, that's all of our operations. Let's go to simulate and see what that looks like. All right, making sure we have tail selected so it's easy to see. I'm just going to start dragging the selection so it goes a little bit faster. You're mainly looking for any type of rapid collision. But if there's no red tick mark on your timeline, then you usually should be clear. Alright, that simulation looks good. Thanks a lot for watching, and tune in next week where we go over the last component of the wallets. Now we're going to jump into the actual CNC cutting on our CB machine.